SAS programming challenges in ISS and ISE studies. Different study designs. Introduction. Say for example, I have 12 studies to be pulled into one ISS and ISE study, right? So ISS is nothing but integrated summary of safety, and ISE is integrated summary of effectiveness, efficacy, SDTM and ADAM standards wherever relevant. Now integrated is nothing but combination of something. Now here something is nothing but the 12 studies combining into one study. Different study design. Say the problem it could be, will have study different designs, right? It could be parallel. In one study it could be crossover, another it could be single lamb, open label. So now how to combine all these 12 studies? So the first problem is this, right? So when combining 12 studies, designs differ. For example, say study A and C, they have randomized double design. Then the another study B and E, they have single arm study. Then D and F, they have a crossover design study. Then different analysis populations and definition endpoints are required. So this is the problem. So let's see what is the solution and how we can handle this. Now the solution here is to create a metadata table that will include records related to design type, then randomization strata, then treatment arms, control or comparator, or it could be placebo, then the blinding type, whether it's blinded or double blinded or it's an open label, then the specific key protocol, specific analysis rules that you are designing. Now all these pooled analysis decisions, it should be based on the harmonization SAP. Harmonization is nothing but sync into a common strategy that needs to be applied into the 12 studies. Now that maps design differences to the pool strategy. Now say for example, I have treat single arm studies as external cohorts or exclude some pooled efficacy analysis. So the very first thing is to develop the harmonization SAP, and based on this harmonization SAP you can prepare the metadata table with respect to these records. Now, say for example, I have studies A to D are randomized placebo controlled, studies E and G are single arm extension studies, whereas studies H and L are different dose comparison trials. Now the step is to build the DM underscore design data set. Now this data set is just a temporary one where you will combine the 12 studies into one data set, which is DM underscore design with variables as study ID, design underscore type. Like say for example, whichever study type it is, you will mention in this particular variable. The arms, whether it's placebo, parallel or crossover, so those arms will be present here. The randomization variable, so if it is randomized, the randomization number and whatever is the sequence, if it's a crossover, so all those information will mention here. Blinding flag, whether it's a blinded study or not blinded study or a double blinded study. So here what you can do is you can represent flag as 0 1 2. So 0 could be represent as not blinding, then 1 it could be blinding factor, second it could be your double blinding factor, right? So those kind of flags depends on what the requirement of the study is, and the depending on the type of studies that you're trying to merge in ISS and ISC study. Then the primary underscore endpoint. Now remember one thing, in these different 12 studies, it may so happen that the primary endpoint will not be same. It will be different from different. So what you can do here is study wise, you can mention in this particular variable what are the important primary endpoints in each and every study. So this design DM underscore design dataset will give you the complete picture. So you will have collected the base or the foundation that you require. Then for ISA you can create analysis flags per subject. So say the pooled efficacy eligible, 1 if it is eligible, 0 if it is not eligible. Now this again depends on the design mapping. So whatever the design of the study is, based on that you can do the respective mapping, also based on the primary endpoint, right? So say some study you may not have the primary endpoint, so you have only safety data, so in that study you do not have any efficacy variable to be analyzed. So in such kind of records or for such subjects, you will have efficacy eligible is equal to 0. But it is not possible that safety also will be 0. No. Some studies it could be safety controlled, some it could be efficacy, some may be both. Right. So based on that data and availability, you can assign the flags. Now for ISS, create safety pooling usually includes all studies. So it will include all studies, and anyways the first criteria for any clinical trial is to detect how safe is that particular testing drug, right, in human patients. So the safety pool flag will be equal to 1 for all, that is but by default. And for event comparisons, stratify by study design and models. So say event rate comparisons, like say you are calculating the survival analysis, right? So for survival analysis you will have censored, uncensored. So in certain design models, if it is having a event rate comparisons, say for example the oncologist therapeutic area, so in that study you need to also create the flag for censored and uncensored, depends on whatever is the availability of data. Now this presentation is just for an example for your better understanding, so that you get the correct exposure for handling the different study designs and combining into one ISS and ISE study. Many thanks for watching my video and happy learning. Please like, share, subscribe, leave a feedback comment. Many thanks for your support and having great connection.